Okay, well,
Go ahead.
my name is Harry Ricker, and I'm an electrical engineer, and I have a master's degree from University of New Hampshire. I went to Virginia Tech. I don't have my Virginia Tech hat on. I should have put that on. And I'm going to talk a little bit about dissidents and why dissidents don't believe in relativity. And that's a subject that we've talked about quite often. I'm going to give my little personal story, which is when I was growing up, my father wasn't an Einstein fan, so maybe that helped a little bit. When I was in college, I had a friend of mine who was a philosopher who explained to me why Einstein was wrong. And I don't really remember a whole lot of the details, but he spent a lot of time proving it to me. He was a religion major at the University of Virginia. And I didn't really understand what he was talking about. It wasn't until many years later that that sort of began to resonate with me. My main reason that I got involved in looking at relativity was because as an electrical engineer, after I retired from the telecommunications industry, I started looking into electromagnetic theory and, you know, what is electromagnetism. And what I found out is that relativity and electromagnetism are basically merged together. So you can't really understand what people are talking about in electromagnetic theory unless you understand relativity, because relativity says magnetism is a relativistic effect. Now that really, I mean, that doesn't make any sense to me. I'm sorry. So you kind of get that as a starting point. That doesn't make sense. The next thing you find out in electromagnetic theory is unipolar induction. I started reading about unipolar induction. I ran into A.I. Miller, who people may recall wrote a book on Einstein's theory, where he discusses Einstein's 1905 paper in detail. And he took the view that unipolar induction was one of the fundamental ideas that Einstein started off with to develop his special theory of relativity. Well, when I started looking into that, that didn't make any sense either. So the more I looked into it, I started studying the math, I started reading all these books, and the more I read about it, the less I was convinced that it was something that made sense, that was valid physics. So that's the troubling question in my mind. That's how I became a dissident, if you will, particularly with respect to modern physics. And I got there by, I just don't believe this special theory of relativity stuff at all. So that's kind of my starting point. And when people talk, I would like to sort of hear what you have to say is, what was your starting point? What made you think something was wrong? Like in my case, I was exposed to a fellow in college who was convinced that Einstein was wrong, but I didn't understand it. But afterwards, after I started looking into it many years later, the more I looked into it, the less I believed it, and the less I believed that it made sense. And I think a lot of dissidents have been on this path. So I would like for, I want to hear people's opinions about this, but I'm really interested in that aspect of, is it convincing to you? I feel that the real issue that dissidents have is they're not convinced of this theory of physics, this relativity theory, since it buttresses electromagnetic theory. It's intimately related to electromagnetic theory and sort of justifies electromagnetic theory. You're going to get people like me who are electrical engineers who, you know, this whole idea about what light is and how light travels through space is kind of a big issue, and that leads you into ether theory. But my main point is, I'm not convinced the theories are correct. I think they're false. And since that's my position, I can't really put any faith in the rest of what physics has to say. So it kind of comes as a shock to me that physics profession doesn't want to straighten out this point of confusion. So what we have is a lot of people who don't believe in Einstein's theory and don't really trust physics. I think that's an issue that the physics community needs to correct. So that's my main idea that I think we should be talking about, our starting theme. And I'd like to hear from some other people basically what their view is. Do we have anybody else that wants to talk, Dave?
I can get
now
people.
I want to remind you that I'd sort of like to hear a brief, succinct statement. I'd like to hear from Steve and Brian, myself.
Okay, Stephen, you there?
I'm here, happy to talk.
Go ahead.
So let's see, Harry. Good to see you. I do see you have your college hat on, and I don't know if I'm on video or not because I can't really.
Okay, how do we turn the video on? Maybe we need to learn that.
Yeah, we'll figure that one out. Okay, well, we'll play with that one. So, succinctly answering your question, right? I sat around with people, we chat about fun things like physics, and just asked the question, why can't you go faster than the speed of light? And of course the answer came back because Einstein said so. And, well, okay, so he said so, so what? Where does he say it? Where's the limit? Where's the speed limit? And just finding the answer, or trying to go around about finding the answer, became the rabbit hole, the proverbial rabbit hole that I went down. I agree, Harry, that there is, I was taking notes as you were talking, let me just pull those up. I think that while some of us believe that there's confusion in Einstein's work, and we see that because when you look at 1 plus 1 and you get something that says 3, you really want to ask yourself, well, that disagrees with my understanding of 2, what's going on here. I think what's happened in a large part of the community is they've found a way to believe that 1 plus 1 equals 3, convince themselves of that, and continue to move on. So it becomes a very hard challenge, as David, you faced it before we were recording, as Harry, you faced, as you shared. It's a very hard challenge to convince someone to change their belief system. So I don't think all of physics is necessarily, Harry, you used the word confused. I'd say it's really they have come to believe that something behaves a certain way. They've come to believe that theory exists a certain way. And that becomes a very hard proposition for us as a community to figure out what is really going on, to expose that, and to ultimately change that belief system. Hopefully that was short and succinct enough for you, Harry, because I know we have a lot of people on the call today.
Correct. My point of view is that, and I like the reason I wanted you to talk first was I liked your presentation that I looked at on your website where you asked the question, did Einstein prove his claim about the velocity of light being the same in the 2 different frames? And you said, and this is what I really liked, you said, did Einstein prove it? And that to me resonates to me because my issue is I don't think that the physics books have proved that what is being said or what is being claimed is true. I don't see the proof. I don't see the proof. Where is it?
Actually, thank you, Harry. So on that one, that's quite interesting because one of the things I've come to believe, and so this is just my belief, is that the only way to positively challenge Einstein's work is with Einstein's work, meaning if he says 1 plus 1 equals 2, you can't come up with a whole new way of doing math and say, and this is why he's wrong, because people won't believe that. So you have to stay within the context of what he's offered and what he's written in his paper. in his paper, he does say, we must now prove that the two postulates and the work that he's done in this math are compatible with one another. He does some steps, and then at the end he says, so therefore, we've now shown that they're compatible. And what's very interesting in this particular proof is that he textually he tells us what we have to do. We have to start with a spherical wave, which is just think of it as a wave of a certain radius, and you have to end with a spherical wave. Again, a wave with a certain radius. And what we've shown, or what I've shown in that piece that you mentioned, Harry, and also presented at a past MBA conference, is when you really analyze that latter part, did he form a spherical wave in the transformed frame? Meaning at a specific instant in time, does a spherical wave exist in that second frame? We find that he did not do that. So the equations, if you look at it, if you don't really dig deep, it looks like it's past, but the reality is the equation works because the new sphere only exists if you allow it to exist at multiple instants in time, which, using Einstein's own words, doesn't satisfy the conditions of the proof. So thank you for highlighting that one, Harry.
So your issue is he didn't really prove what, at the fundamental mathematical level, he didn't prove his case. And I looked at this as well and came to the same conclusion you did.
Yeah, exactly, and that's the start. There's some very interesting things. There was one person in one of the forums, I think the relativity forum, who had mentioned a comment about Einstein's partial differential.
You're figuring out.
Sorry about that. I'm a little bit far from my computer here. There is a question that came up about Einstein's partial differential equation that he uses in his proof. And I'd have to say that because it's understanding partial differential equations, as you know from your electrical engineering backgrounds, right? It takes a certain level of math before you're even exposed to that as a technique. I think as a result, we have a lot of people who look at Einstein's work and they see that, and either it trips them up or they have to gloss over it and keep going. And that step is probably one of the most critical steps in Einstein's work that isn't really well developed in analysis, and it is one of the things that I'm hoping to provide some greater insight on later this year once I've been able to finish my book, and hopefully share a little bit more at the upcoming NPA conference in August.
Well, that's I like your I like what you say. Like as I said, going back to it, I wrote a paper on the light sphere paradox, which is, if you look at the books, there are not very many books that discuss the light sphere paradox, and this paper is at the General Science Journal under Harry Ricker. You can look at it, and I tried to look at this issue of the proof. Are the two sphere, does the Lorentz transform the sphere in one frame into a sphere in another frame? And I couldn't, I looked at the math in detail, and I did analytic geometry and tried to use some sophisticated math, and I couldn't come up with any way that proved that you can transform a sphere in one frame into a sphere in another frame using the Lorentz transform, and I couldn't figure out how any of that math is correct. So I sort of right there start with the position, if you can't demonstrate that the math used in the fundamental proposition, which underlies all of the theory of relativity, is correct, if you can't prove that math really works, and I can't, it looks like the proof is broken and doesn't work at all. And so that's a fatal flaw as far as I'm concerned. Do we have any other comment? Anybody else? I see one flag by David V. Connell. But does anybody want to talk about this issue of did Einstein prove his fundamental proposition? I don't think.
Who did you want unmuted?
Well, is anybody raising their flag? This is kind of, I guess we're going to have a learning experience here.
Yeah, I don't see anybody. How about Roger Anderton? He had just, like I said, he was on a program talking about Einstein being wrong. Did you have any comments, Roger? Let me, he's in the UK, so let me find him here.
Hello.
There we go.
Yeah.
Okay, go ahead. You there? Go ahead.
Right, okay. Well, I like to say where I'm coming from looking at Einstein, and the issue of the sphere, I think, is a red herring. It's a diversion to what's really going on, because Einstein's changing lots of things from how you normally treating things, because for Einstein, length can contract and time can dilate, and so that's not normal things what were used to before Einstein. So when you get onto issues like the sphere, well, that he's changing all that as well. So when you're talking about proving something about a spherical wave, it doesn't really mean anything in that context, because Einstein.
So you're saying his proof is wrong?
No, he's just changing everything. So
well, that doesn't mean anything to me.
So what he would
doing physics here, and in physics
yeah.
and math, we're doing math and physics, okay?
Yeah.
And what you're looking for is you're rigorously proving something is so. And in mathematics, you're proving things that are abstractly defined. In other words, you make abstract definitions, you take abstract objects.
But
and you manipulate them mathematically, and you do proofs with that.
Yeah.
And what Stephen says, and what I'm saying is that when you look at the supposed proof, it doesn't really prove what it purports to prove. Therefore, the proof is not a proof.
Yeah, but Einstein's changing everything. So a sphere.
That's an irrelevant statement.
What do you mean? Isn't a relevant statement? It is what he's doing, because in Newtonian physics you wouldn't be dealing with time dilation and length contraction. So
that's what they say in the physics books. They say, well, because everything's changed and we don't have any. It's okay that the proof isn't really a proof because, well, there is no such thing as time and there is no such thing as space because we changed it in relativity and we changed all these definitions around. So you can accept our proof that doesn't really basically rigorously prove anything.
Yeah.
So I think that your discussion is red herring.
No, I think yours is, sorry. Einstein is changing everything. When you're doing a proof, you in Newtonian physics, you're sort of like assuming Euclidean geometry. And when Einstein's doing things, he's changing all that, and it's non-Euclidean geometry. So things like a sphere in Euclidean geometry is not the same thing as a sphere in non-Euclidean geometry. So you've got all these changes going.
This isn't relevant to the discussion, Roger.
Okay, that's okay.
Well, I think it is.
It was my idea to have him talk. If it's a different part of the discussion, let's just go ahead. I'm going to mute it. Thank you, Roger.
Thank you. Cheers.
I guess we're trying to get that. I apologize.
So
I'll
just summarise. You just want to misrepresent what Einstein's doing. That's why you're creating all this diversion. Mainstream just doesn't recognise what you're saying. You're just not looking at it the way they're looking at things. Thank you.
Okay, well, we have the different opinions for sure. Let me just go ahead and put him on mute there. Well, it is a very contentious, even amongst ourselves, and I think there's a couple of things I just like to say, and maybe other people can have some opinions on it. When you look at the technical side, there's a lot of arguments. I mean, I got into all this because of Karazani, who has some really excellent technical arguments as to why special relativity is wrong and what went wrong. But the other thing is, too, is that it's not so much that people are, this is my opinion, I don't think mainstream science, I don't think professors, I don't think universities discuss the level that we discuss at all. It's sort of studied, it's sort of talked about, you take your test and you go on. The actual application and use of it is almost nil. And the only place I see it used a lot is in particle accelerators and using the equations, the relativistic kinematic equations. But when I was the guy from Stanford Linear Accelerator, he said he had to unteach special relativity. He doesn't observe mass increase; it's not there. Yes, yet they use it. So I mean, there's a whole other component that's not just the relativity and the mathematics behind it. And I think at times, at least in my opinion, I don't know what other people think, we're discussing a lot, even though it's extremely interesting. That's where I came from, the actual mathematics and where it went wrong. I don't think that's that's not happening at all in mainstream science, don't you think, Harry? I don't see that people are discussing it at these levels. I don't think they can. I don't think
Well,
they
David,
understand.
I'm afraid that we dissidents aren't doing a very good job either. And I
Yeah,
think the
no, I
previous
agree.
discussion was a perfect example of what you have is you have Roger Anderton who has this pet theory, and he says that I'm wrong. Okay, well, that's okay, but that doesn't really get us very far bickering. Um, the issue that I'm framing is I want to see the proof that it's right. And I don't want to hear somebody say, well, you got to take into account that they changed the definition of time and simultaneity, and length is changed, and all these things are changed. That doesn't really help me to understand that it's true.
Right. I think the point here is, and this is to Roger too, is that we're looking at a specific part of the discussion right now, and that's not what we're talking about. We're talking about we're trying to make the discussion in pieces. And it's sort of my fault for just jumping in the middle and trying to get somebody there. But the idea is you're saying is show me it's correct, and I think what I would say, Harry, is the truth is that most people are already past that it isn't, and the problem is they're stuck with it in the media. They're stuck with it in um, particle physics. They use the neutrino to get themselves out. They don't know that. But the experimentalists are not theoretical physicists. They don't like theoretical physicists, and what they are trying to do is go on with their work, even though it's a unicorn world. So, I mean, I would, in some sense, I'm not sure how much other than when you sit in a class and you have a professor in front of you in physics 101 and they're talking about relativity and they give you all the equations and here are the proofs. You go through those, you accept them, most people don't, and you go on, you get your grade. I don't think, like I said, there are people other than ourselves discussing this, and I agree with you too, absolutely. Harry, I'm 100% hell-bent on trying to get information out. If I could, Harry, I would say everybody in the CNPS stop their work, let's get it out there and let people see at least the directions we're going. But one of the problems is too, Harry, it is hard, and you know that, and I agree with you, and that is getting people to discuss. When my first MPA meeting was in 1996, and John Chappell told me, "Oh, were you there when the one guy threw hot coffee on the other guy?" This is why we have Margaret Wortham writing things like there's a bunch of Jesus Christ out there trying to save the world, because we don't even amongst ourselves often look that very good to the outside world, and it's not easy. It's not easy. So you have to balance you have people who, like Harry, myself, Steve, Brian is another person I put that category, who try to look at the bigger picture and look at how these things are going. But it's one of the problems, and this is one of the questions you sort of touched upon, Harry, is the dissident community itself. What are we doing? I'm trying to promote. I had somebody say to me, says, David, you have this software. You don't need to do any more. You need to just promote it, get people out their ideas. On Tuesday, coming up, I have brand new people from meetup.com coming to my house who are interested in dissident science. I'm going to give them an overview of all of dissident science. Now, what are we doing amongst ourselves? One of the things, Harry, that the MPA tried to do, and should we try to do, is to come up with some type of general statement. No one's going to agree with everything in it, but can we, as a group, come up with general statements about relativity that we can sort of make a statement and say, these are general ideas that come from and our conclusions or whatever? Is that possible?
To answer your question, I don't think so, with the dissident community being so difference of opinions.
Well, I mean, one of the things is when I put together the problems that, because one of the things I get all the time is, oh, dissident scientists don't like this, that, and the other. Well, what are the problems? So I listed the problems. They're on our webpage. It's pretty well known. People have seen it. But that wasn't anybody, but I just took it upon myself to put them there. I don't think there should be a problem for us to do a survey, not necessarily a conclusion, but a survey of different ideas. And I think one of the problems, and I don't know if you agree with this, Harry, and I gave a talk on this, is we have this idea that we all have to agree that there can't be 3 theories of gravity, there can't be 3 ideas of structures. I think that's not good, but can't we do a survey, Harry, and say, here are some of the conclusions of people in the group?
Well, I'm not opposed to that. My position is I'm not convinced that what the scientific community is teaching is convincing. So in other words, they're not convincing me.
Sure.
And I would like to be convinced that the scientific community is doing good science, and that when they use what they call the so-called scientific method, that the conclusions that they draw from that method are valid conclusions that are following the method. What I see is that I don't trust the scientific community. I don't trust the method that they use, because their method is essentially elitist, and they talk down to the rest of the people like me and you and tell us this is what you should believe, and that's not convincing. What they're saying isn't convincing. It's not convincing. So
I agree.
they have to do more to convince people that they are honest, that they have a method that produces valid results, and they don't. And they have to listen. They have to listen to what people are telling them. They can't just ignore that. And I think that brings in Nick Percival and his attempts to deal with the science establishment through the twin paradox letter that we wrote, where we asked the experts, clarify this issue about the twin paradox, and they basically refused to answer it. And there's a group in Germany that's they wrote a letter to the German government and demanded that the Einstein Institute give a clear answer as to how relativity should be interpreted, and they didn't have much success with that. But Nick could probably talk to that more. That's, I think, kind of disturbing. Why can't they give us a clear answer to a request from the citizens in the country? In Germany is a particular example where they have in their constitution that I forget the details of it. Nick can talk to that. Is Nick there? Can he talk to this issue?
Hi, Harry. I'll try and talk loud. Tell me if I'm not.
You're not that loud.
Okay, I'll try and overcome the fact that this seems to be a weak connection. I thought I would start off and segue into what you asked about. Go back to your original thing.
We can hardly hear you, Nick.
All right, let me try again. Can you hear me now?
Yeah.
Okay. I'm just going to talk about sort of the evolution of my thinking on relativity. When I entered college, I had one assumption, and that was that my professors and textbooks were correct. So I sat and I listened to special relativity, and they talked about all inertial observers are equal, and if A observes time dilation and B observes or experiences the same for A. So ultimately, I came across Life magazine. This was in the days of when the astronauts were first taking off. And it said if an astronaut goes from the Earth at high speed and comes back, he'll come back younger because of special relativity. Well, I said, this is crazy. We have the time dilation equation is symmetric. You can't have an asymmetric result from a symmetric equation. So I went to my professor and I said, hey, you got to write a note to this idiot journalist who knows nothing about physics and is claiming that there's a net proper time difference for an astronaut. And he said, no, that's what Einstein said. And my jaw dropped. I couldn't believe that. And that's what really triggered my discontent with special relativity.
So your discontent is that this journalist wrote an article and made a claim, and it didn't make sense to you, but you were told in answer to it that that's what Einstein said, so therefore it was right.
Exactly, yes. And we talked a long time, and I actually thought at the end of the conversation that I'd convinced him that I was right because he wasn't coming up with any good counterclaims. But, you know, obviously that's what the special theory of relativity is claimed to say. So for the next 50 years, I engaged in dialogues with various professors. Most of the time they would just say, you don't understand special relativity. But they couldn't give a convincing rationale of why there should be a net proper time difference. Finally, I changed my debate methodology so that I would only ask them questions about what they believed, and ultimately it would come to a contradiction, and I could get two reactions. A couple of physics professors agreed in writing that what they had been claiming was wrong, and a couple, even though the final question would take 30 seconds to answer just using straightforward special relativity, when they saw they'd come in, they'd been led into a trap, they exit the debate and save face. But that convinced me that no amount of discussing the logic problems with special relativity was going to have any effect on the mainstream. And I'd just like to also comment, the second postulate of special relativity talks about the speed of light being the same in all inertial frames. I don't think that he necessarily has to prove that. As I understand it, there are some people who claim that experiments show that that's not true. But I'd accept that as a postulate as long as the consequences of that postulate yield viable results. According to Einstein and his twin paradox claim, it leads to a contradiction. So I shifted my focus to looking at the GPS system. And the GPS system clearly shows that the data on time dilation or clock retardation is asymmetric. And no one disagrees that the special
You're fading out.
time dilation equation is symmetric. So I'm hoping that hard empirical evidence from a very credible and ubiquitous system will eventually sink in to the physics community.
Nick, can you hear me?
Yes. Yes.
Here's a question I have for you. I made a movie with a guy who's in Stanford Linear Accelerating saying there is no evidence of mass increase. That in itself is proof that special relativity doesn't work. What I found, let me give you some insights, is the politics that was going on. I couldn't go in the Stanford Linear Accelerator because the community called me 5 days before and said it was not in their best interest for me to be there. Why did this experimentalist who knew what I was doing talk with me? And the thing is that he talks with me because the experimentalists and the theoreticians don't like each other. They're very combative. Now, the thing is that we have evidence. The people themselves at Stanford Linear Accelerator, what more do you need to say? What do we accelerate closest to the speed of light in anything we do? It's particles. And they don't see mass increase. And they say, we see no evidence of this. If this were anybody else's theory that wasn't accepted, it would be immediately dismissed. Why isn't it dismissed? I mean, you're talking about proof, but obviously they already have it. Why aren't they taking it?
Well, as others have said, it's not really science. It's become a philosophy, it's become a religion, and a lot of people have their egos are totally wrapped up in relativity. But one of the big problems is, as many say, the modern physics, at least space-time physics, is built with special relativity as the foundation. So the problem is, and I'm 100% convinced that special relativity is wrong, and when you build an edifice on an invalid foundation, then you have problems. Regarding general relativity, I don't think the case in general relativity is quite as bad, because the law of gravitation in general relativity was derived without any reference to, well, only marginal reference to special relativity. And then they expanded it and talk about the kinematics and dynamics of curved space-time, and when they did that, they brought in a lot of the errors of special relativity on top of the law of gravitation.
You're fading out a bit, Nick.
They went on to, they find errors all the time, empirical data that disagrees with the theory, and the best way to win a Nobel Prize is to find some fudge factor that will resolve these differences between theory and empirical data, and come up with dark matter and dark energy and inflation theory and things like that.
Okay. Could you summarize a little bit about what happened when you sent out the open letter and what the response was?
Okay.
You need to speak up more.
There were two main responders. One was a Nobel Prize.
You sent out how many letters, 20 or 30 or 40? A bunch of letters to all kinds of people, right?
Yeah, I sent that out to all the major universities, all the major journals, individual physicists who had a reputation, and I got back just a few answers. And
so you only had two people that actually bothered to respond.
Well, now there were more, but of the prominent ones, two prominent people responded. And the Nobel Prize winner essentially said that all of the reconciliation arguments for the twin paradox were simultaneously correct, even though they were mutually exclusive.
So in other words, he said that there are multiple there's multiple realities that are all simultaneously true.
Yes. And
that's a big problem.
I have a page on my website which is called twinparadox.net, and despite the name, I'm shifting the focus to look at the empirical data, including GPS. But there's also all of the discussion about the logic of the twin paradox is still there.
Okay. Now, what about
there's a page called the mainstream response, and I didn't do any editing. I'm giving 100% of what they responded to with, and people can go and read that page. And I think it's one of the most compelling indictments of the mainstream position. Now, the other person who answered was from the Albert Einstein Institute in Germany, which, as you said, the government has designated that as the official spokes organization for relativity. And the law says that they need to respond to questions about relativity. And
So they're required by German law to answer questions.
right, right. Somewhat similar to like our Freedom of Information Act. And the German folks over there, people like Jocelyn Lopez and I think his name was Eberhard,
Eberhard.
have formally asked, when you talk about time dilation and length contraction, are you talking about asymmetric, real physical effects, or are you talking about just observed effects? And they will not answer that question. That's pretty amazing.
Okay, so you faded out a bit. So you asked so they were asked by these people in Germany in their capacity as the governmental authority, they had the responsibility under the German law to answer the question to distinguish whether the effects in general relativity were, as you say, just observed or apparent versus real and asymmetrical.
Yeah, actually, in special relativity.
In special relativity, and they did not answer.
Correct.
Okay, so they either don't know the answer or they don't want to reveal that they don't know the answer, or they just don't want to be bothered.
And the answer from the AEI to questions about the twin paradox are also in the mainstream response. And one of the things they say is that GPS proves that special relativity is correct.
Who said that?
I'm forgetting the guy's name offhand, but sort of the major professor at the Albert Einstein Institute in Germany.
Okay, so now this is at www.twinparadox.net.
Correct. The main response page.
Nick, this is David. You know what we should do, and this I think we should do, is make this. You have everybody has not everybody, but the members have blogs. Paid members have blogs on our site. We should keep this as a reporting up to the date kind of thing going on. And and you can do it in a, how do you say, historical way. Maybe go through what you've been doing in a series of articles, and put what people's responses are. Put it under relativity, and keep people informed. I mean, one of the things is if it's on your site, one of the things about the difference between an individual site and the site we have with everybody together is just that you have numbers. You notice I put that map up of all the dissidents. You got 2,000 little bubbles around the world. It makes it a little bit more prominent. But I think this whole argument you're doing is going to expose them, at least to the public and with answers. For instance, when he says GPS, when they say GPS supports special relativity, well, we can point them out to Ron Hatch, who has 30 patents, who basically in my movie came up with a quote. I said, Ron, give me a quote from you who have 30 patents in GPS about relativity. And this is what his quote says in my film. It says, relativity doesn't show how it supports, GPS doesn't show how it supports relativity. It exposes its flaws. Now, I think what you're doing is excellent work. But let's start. One of our biggest problems with all of us is no one knows about it. And I'm not saying that you haven't been trying to get noticed, but at least in this point we have a place. When you have it in a blog that is changing often, like ours, it gets indexed more, etc. So is that something you could do and start, organizing and maybe weekly giving us at least, every week give us a little bit of the history of what you're doing, the responses, and that way we'll get it onto our site as blogs, and I'm trying to get a lot of people in there doing that. Is that something you could do?
Yes, I can do that. I'll just add, it was very interesting to me that as an individual dissident with no official backing by anybody, that the site gets, for the main page, there are 500 or 600 a month
Right.
people visiting. I'm
Sure.
wondering who they are. I'm surprised there are that many. I think they must be word of mouth that physics students are going there.
Well, I think what happens, those kinds of, the way it happens is a little less, how do you say, where we put often too much analysis in it. What really happens is that you have people going out there and Google and they hit it and they want to read stuff. So people will fall on it. When anybody doing things about Einstein, doing research on Einstein, you have to remember today and age isn't the same when we were going to school. We went to the library and cracked open books. You had the equivalent of, well, I've checked this book out. You can see how many people were checking that book out. Well, people are writing stuff all the time. My daughter in the 4th grade brought a book home on gravity, and I was going through it, and I was just laughing at what they say, the sweeping statements they made about Einstein in there. I mean, just sweeping. One of them was shocking. In this book, 4th grade, my daughter, it says, Einstein's relativity gave us many inventions. That's in her book. So what happens is people are making these, they're reading about it in the index, and they're going to get to your site because you have a lot of hits on Einstein, the word Einstein. So you're going to get a lot of, that's great to know. But what I'm saying is when people come to a site and they see other people, one of the symptoms, unfortunately, is the lone dissident can be easily attacked. And I'm not saying what you're doing is that's happening to it. But I'm saying one of the ideas, when we're together and we have articles, we have Pollock writing about water, we have Crothers writing about black holes, we have James Maxwell writing about expansion tectonics, everybody contributing to this, you writing about this fight that you're having, people will, how do you say, when you're going down the row of restaurants in a mall, and you see everybody in these big lines and this other has very few in that line, people will go away from it. So hopefully us getting together that will help. But yeah, I mean, you are getting that, but is that something you could do for us to move that over there? Because a lot of times we just don't have time to see it. When it's there, people read an article about it, right? I mean, how many websites do we have represented by all of us? There's quite a bit.
Yes, I can do that.
Yeah, I think that would be great, because I think this is a fascinating fight. But to get back to it too, Nick, again, what we're dealing with is, I honestly think, here's, to put it brutal, we talk about it because we know science is screwed up. Harry and I and my dad and everybody else, and my dad's an electrical engineer, we're fed up and we're tired of science because it's just giving us baloney. The problem is that we are making a little storm in a teacup, and the rest of the people, including experimentalists, they look at this as not even interesting. It's almost like this is a mess. This is full of paradoxes. The theoreticians have run amok. This is a guy who's experimentalist at Stanford Linear Accelerator, which, by the way, one of the CNPS members is going to start being one of those people coming very shortly. With those people, they want to just like unteach it, get it aside, and then move on. Why do you think they don't want them to mention this? Why do you think the experimentalist was standing out in the field with me, not inside, going against his entire community to say, talk about and say that he has to unteach fantasy to these guys?
Well, David, you're jumping ahead in the program a little bit.
Oh, sorry. Go ahead. I'm sorry. Get off that. Go ahead.
That's an issue that I wanted to talk about. There are 4 issues. One is default philosophy. I look at it, there's philosophy, physics, math, and experiments. And those are the 4, the 4 categories that I see that you can sort of lump the different issues in. And we talked a little bit about philosophy. Nick talked about philosophy, and that when he asked this guy, the Nobel Prize winner, his response was, there are multiple realities, all equally true. I mean, come on. I mean, to me, that's just that boggles my, that violates everything I understand about philosophy of nature and how physics works. I mean, that's a completely bizarre philosophy of science, that a scientist, a Nobel-winning scientist, could say there are multiple realities, all of which are equally true, is just bizarre. That, I can understand how an experimentalist would say this is ridiculous, that theoreticians are saying ridiculous stuff. I mean, that's ridiculous. How can you measure something? Everybody's going to measure something different. That's not physics, okay? So that's a problem right there. And then the other experimental issue, which is in the category of experiments, we have GPS, which seems to basically refute the theory in terms of the way it's set up and how it does measurements. So, and that's another subject. I mean, there's lots of experiments that don't seem to fit into the theory of special relativity or general relativity. They just don't fit into the theory. So that's just like, well, how can I trust science is supposed to be based on experiment when, I can read these papers and it says here these experiments disprove special relativity. I mean, why are they still teaching a theory that's disproved by experiment?
We get into the politics of it. Before I go on, just to get everybody on track.
Well, my point is, I'm not interested in the politics of it. I want to know I want I want science that's true, or at least is not full of contradictions, not full of experiments that disprove what is claimed to be true. I don't want that. I want something that's contradiction-free, that makes sense.
This is an announcement for Fuse.
GPS.
Hold on.
Is consistent with what general relativity says.
Announcement for Fuse, if you can hear me. For those chatting, there's a little button at the top that has two little conversation bubbles. What's happening is I see everybody chatting, and unfortunately the default for this is to chat amongst your own self. And so the way you chat to everybody is you see all those little letters. They're usually the first and last name initials. That's how they do it, or a picture if they have one. And then if you click on that two bubble thing, you can get in there. We've got myself, Steve Bryant, and Daniel in there. So we would like to keep the conversation going, and to read it is to go and click on it. Again, that's how you do it. Sorry to interrupt, but I see a lot of people chatting to themselves, and I apologize. We're learning that. Go ahead. Go ahead, Nick.
Okay, we're just saying that in GPS, basically the general relativity part of the main algorithm seems to be consistent with the data, but special relativity is like 180 degrees out of phase for half the data.
Yeah, but again, here you have in GPS a system that is based on an absolute time. There is one and only one time in GPS, and relativity is based on the fact that there's no such thing as absolute simultaneity, and GPS is based on the fact that there is absolute simultaneity.
Well, Harry, do you know what Ron Hatch's answer to where the absolute coordinate system exists in GPS? He has an answer.
I'm not sure. I'm not sure what you're driving at.
What he said was that one of the problems of relativists is that they put the center of their calculations in everywhere but the center of the Earth. And he says GPS absolutely puts all calculations in relation to the center of the Earth. Everything. He says everything works out fine then. He says the problem with relativists is very similar to what Karazani found, and that is they start putting more than one frame, and there isn't. Well, the way I have, after knowing Karazani, I boiled it down to this. The universe has one three-dimensional space.
Can you speak up, Dave?
Really? Okay. The world has one three-dimensional space, and that you can only move its origin. You can't have two frames. And that's what Ron Hatch also says. He says that for GPS, there is the ultimate frame of reference, would say always use, is the middle of the center of the Earth.
Well, one frame, one coordinate system.
Right, but the problem is relativists put the coordinate system up on the satellites.
Yeah, that's where, you know, I said there are four issues. There's philosophy, physics, math, and experiments. And now we're talking about the math problem, which is in relativity, special relativity, you have multiple coordinate systems, which each coordinate system gives its own, each coordinate system has its own reality, different from every other coordinate system or frame of reference. So you can have multiple realities because you have multiple coordinate systems. Is that acceptable as philosophy? Now, is that acceptable as math? Well, I think it's not acceptable as philosophy, and I think it's not acceptable as math. And what you just described is GPS finds they can't solve the equations unless they use only one coordinate system, and Karazani came to the same conclusion. You only should use one coordinate system, right?
Yes, absolutely. Well, it's not even that you should use. What Karazani found out was very simple. Two things he found out. One is that, I'll put my video on. One is that frames are mathematically boiled down to one. That is, one's redundant. It's literally, you can show that mathematically. So mathematically and physically, two frames make no sense. So that's what he found. It wasn't even a case of it's preferred. He said, you know, you can't justify it. I mean, mathematically, if you gave it to a mathematician, it'd be like saying 2 over 2 is not 1. It's a different thing. You know.
So there's a fundamental math error there.
No, it's not a fundamental. The error is in separating. Here's what the error is: when you have two frames, you're doing the calculations. Okay, that when you are then assuming the velocity is in between these frames is real, and that the change, that there are two frames and there's a change. That's what it is, right? Relativity has to do with a frame, and this frame is moving with this frame. He says at that point, mathematically, you can't justify the two frames. It's not a case that you can do it and you've got an error. The problem is that it's mathematically unjustifiable. Like I said, it's like saying 2 over 2 is not equal to 1 because you have a different system. It can't be. So the moment you split it out and it's changing and you do the delta changes from one frame system to another, you then take the math for that, you can reduce it down, and the reduction is only translatable to having one frame. One frame disappears.
Well, that's interesting. I'm going to have to. Do you have access to Karazani's papers on the CNPS?
It's online at autodynamics.org.
Is that like a
website?
Yeah, that's his website. But is that proprietary? You can't link to that?
I'm the one who did it for him. I
Okay.
did all for him.
I was just thinking that if you could link a lot of these resources from one place, it would be improved.
Yeah, I think we can do. You know, the way to Gurr, you're there. Who is GRRR? Hello.
Hi.
Yes. Who is speaking?
You hear me?
Yes, but your name is not GRRR.
No, I'm doing tests because this fuse thing is all scrapping up on every computer.
Oh, I know who you are. I don't remember your name.
Okay. All right. Well, I just wanted to comment too, as a lot of discussion's been going on. First, quick comment. I'll try to do this quick. Mathematically, special relativity is coherent. What I've noticed in schools, universities, and that, when they teach it in physics, physicists are not mathematicians. Like, they just apply the formulas blindly. They make a lot of mistakes, and they can't do the calculations right. But if you put the same problems to a group of mathematicians, they all consistently get the same answers. They know how to do the math. So special relativity is mathematically consistent. Now, as whether does it apply to physics or not, that's more the physicists to decide. Do they want to use that mathematics, that theory to describe the reality? That's all up to them. Apparently, it does fit their observations. Like when they do measure the speed of light, anybody who measures the speed of light actually all get the same result. That's experimental, you can't deny that. And there are many other experiments which also support that model. Now, there are other experiments that don't support it, but those other experiments are also not part of the basis of special relativity. Special relativity has a very limited domain. Some physicists try to apply it everywhere, and that's when they run into bugs. They're not supposed to apply it everywhere. They can apply it wherever it works if they wish, or they can apply it where the theory says to apply it. But physicists just randomly apply it anywhere, and that's their philosophy. They say, we will apply it there where it works. So let's do experiments, and there where it works, we'll say it works. There where it doesn't work, we say it's not applicable there. And that does work, that type of reasoning, we can say, or that type of philosophy. They want to use that consistent mathematical theory there where it suits their needs. And hence, they play with it on in all their experiments. So those are the first few comments, so I'll leave it up to there.
So you're saying that the mathematics is correct, it's just not applicable to the physical world that physicists try to apply it to.
You'll have to repeat that. I had a overlapping message.
Yeah, that's what he said. That's what he said. Let me make a couple comments on
Well,
this.
let me repeat that. What did he say? Because I don't.
He's saying that I'm going to
He's
address.
saying that the mathematics is correct, but the physicists are applying it to the physical world incorrectly.
Yeah.
To me, that's the
In
same
some
thing.
areas.
The
Yes,
mathematics.
yeah. In fact, the guy I interviewed, an experimentalist, he said the same thing. Here's a couple of answers I have. Again, what's your name? I'm sorry.
It's Bones.
Oh, Bones. Okay. I'm gonna mute you because you're getting back feedback. Let me address a few of these problems. First of all, to say that it's mathematically consistent, then you would have to read Karazani because that is a person who's shown that not true.
Can you speak up, David?
Yeah, I can speak up. You can talk with Kara. First of all, he's saying it's mathematically consistent. You have to read Dr. Karazani's work because that's been disputed. Secondly, you say that the speed of light is measured the same everywhere. That in GPS has been disputed. The other thing is you say they over-apply it. That is their argument. I agree with this. That's what they say because the experimentalist at SLAC said exactly that. The problem with this is his, I'm not saying it's right or wrong. I'm just saying this is what he said. This is interesting to you, Nick Percival. The guy from Stanford Linear Accelerator, in the film, he says that. He says that you can't apply special relativity to the twin paradox because you're applying something that shouldn't be applied to that. The reason he says it's only because he says it's a one-way constant movement. It doesn't deal with acceleration. Now, whether or not that's true or not, that's what they say. So I agree with you, Bones, that they are applying it where they shouldn't be. I very much disagree with the idea that that there's consistency of light speed. There's a lot of people who have shown that, including GPS, that it's C plus V. And GPS, Ron Hatch, who has 30 patents, will tell you that. The other thing is, too, is that that it's mathematically consistent, and Dr. Karazani has shown that, in fact, it's reducible. It's not consistent. It's actually reducible, and therefore the conclusions of mass increase and all that stuff are incorrect because they have not reduced. They've made a problem that should be reduced and must be reduced, and they have done it. That's the argument. Whether you disagree or agree with it, that's what I'm just pointing out there. Okay. Go ahead.
I'd like to say something about what Ben's just said, and that is I struggled with this issue for a long time. And I eventually came to the conclusion that the mathematics of special relativity is correct. It just doesn't apply to the real world. It's just not useful in physics.
Well, the problem, I guess, Harry, it depends on what you say is correct. The correct part is that you can put two frames up there treat them, and then make the calculations. Now the question is whether or not, even though I can mathematically simplify that, and therefore that setup is irrelevant physically, then yeah, we're splitting hairs there. I mean, I think that the case is again, you can say, no, I can do mathematics with everything over 2. You know, 1 plus 1 is really 2 plus 2 over 2 plus 2 over 2. Now the question is that's not really what those numbers are 1 plus 1. But again, that's splitting hairs. I think what we need to do is, in all of this, is to find out what our arguments are, find out if there's enough consistency so we can make some kinds of statements about it. And, you know, we all are doing that. But, you know, I agree that, you know, the problem is you have the physics and you have the math. But I think those who are looking at that should look at Karazani's work to get an idea of it. So
I agree. My view on this is what you have is you have a philosophy, you have physics, you have math, and you have experiments. Those are the 4 areas that I, you know, sort of try to divide the discussion in. And of course, the philosophy sort of guides how you apply the physics and the math. And the physics deals with doing the measurements and interpreting the measurements with the mathematical theory. And then you try to make your theory match your measurements. And then you do experiments to show that your predictions that come out of your theory match the experimental results that you measure. And so you need, you know, physical ideas, you need mathematical ideas, you need philosophical ideas, and you need experimental procedures to do all this. And what the problem I have is I don't really see that the physics and the mathematics really work to the same thing. In other words, they don't really solve from what Bones said is sort of kind of, I agree a little bit with what Bones said, which is the physicists aren't using the mathematics correctly. And so that allows you, because you're not using the mathematics correctly, that allows you to say, well, every different frame of reference has its own different physical reality. That's kind of using math wrong to get there.
I'd like to add something. This is Nick. I would agree.
You need to speak up, Nick.
I would agree with Harry and Bones that there are no mathematical inconsistencies with special relativity. But the math of special relativity has been interpreted to be a physical theory, and that's where things went wrong. One example of where it went wrong is the twin paradox, where they came to a conclusion about a physical effect that's not warranted by the math of the theory itself. But I would strongly disagree with Bones's view that special relativity works where it works, because often it's not really special relativity that's working. Often it's a different theory that's working. Let me give an example.
Oops, you're gone.
Am I back again? Hello?
Yeah, speak up now.
Okay. In GPS, we use the time dilation equation, or something that looks like the time dilation equation. And half the time, it'll work. Namely, the relationship that the Earth clocks see to the satellite clocks. But what's really being used is not special relativity at all, but Lorentz relativity. That's the physical model that's being used, as a number of people, number of the engineers on GPS, not just Ron Hatch, but others, say. So it appears like it's working in certain domains, but it isn't actually working. Another confusion is to think that the only domain of special relativity is inertial frames. That's logically equivalent to saying that special relativity is worthless. The better way to think of special relativity is that it's looking at the effects of velocity per se, and it's getting rid of acceleration and external forces so that you can more clearly focus on the physical effects of velocity per se, because experiment after experiment has shown that the so-called special relativistic effects happen whether the observer and the observed are in inertial frames or not. It's completely independent of inertial frames. Saying that special relativity can only be applied in inertial frames is a complete red herring and a complete misunderstanding of special relativity. But the reason
Well, it's
why
formulated only for inertial frames.
special relativity seems to work is that a lot of physics in terms of accelerators and GPS is done using the ECI frame. And that means that they're really using Lorentz relativity. Because if you tried to use special relativity with some other frame than the ECI frame, you'd get the wrong answer. So I hope that helps.
Okay, so to kind of summarize what you said, which takes us back to the philosophy of science, there might be more than one theory that is satisfied by the experiments and the information that we have. And so there's more than one theory that could be true. It could be special relativity is true. It could be that what you call Lorentz relativity is true. And there are different theories and make different predictions. But the physics community doesn't have any way of distinguishing between the two. So it could be that special relativity is false as a physical theory, because a theory that's similar to it, which you call Lorentz relativity, produces the same experimental results. And so they've made a mistake in identifying the physical theory as being special relativity when Lorentz relativity is the correct theory. Is that what you're saying?
Yes, and I'll give two examples that will further clarify it. For accelerators, they use the ECI frame, and that happens to be the one unique frame of preferred frame theories like Lorentz relativity. And the only measurements are done referencing that frame, that one unique frame. So since you only got data from the one unique frame, the data is consistent with both special relativity and Lorentz relativity. It wasn't until we came up with GPS that we could see get data from two different clocks. And we find that the data is not symmetric like special relativity says, but asymmetric.
So we have basically a contradiction of what the theory would, special relativity is supposedly predicting.
Correct.
That's kind of disturbing.
It should be.
So if science is based on the idea that that what we do is we have a theory and we make predictions, and then we compare the predictions against experiments, that's kind of disturbing that process, that scientific method, is not working properly, in that they've verified the wrong theory.
I've got Cornelius. Do you still want? I saw you had a flag up. Would you? I'm going to unmute you, Cornelius. I'm going to unmute you. You had a flag up. Did you want to say something? Cornelius, I heard you before. Hello. You have yourself on mute. I heard you before. There you are. No? Okay. All right. I'm seeing the flags up here. Let me see who else is up here. I don't see. Okay.
I see Robert Bennett is here. Is Robert Bennett, can we get him to talk a little bit?
Robert, are you there? You're unmuted. So sometimes what happens when people unmute, they have your headset may be on mute, or your computer may be on mute. Check that. I don't know, maybe he doesn't have a microphone. It does say he does, so.
Hi.
Robert, are you there?
I don't know.
Looks like he can talk.
You type in
Maybe
the,
he's not.
Can I add
Maybe
something?
he's not in the room.
yeah, could be. Well, he just muted himself, so. Okay.
Can I add something?
Who's saying that?
Roger.
Go ahead.
Yeah. I've argued with people who believe in special relativity, and when you get down to what they believe, it's actually
still going.
they actually believe Lorentz.
In a second.
Sorry.
Go ahead.
Yeah, I've argued with people who claim to believe special relativity, and when it gets down to it, it's the Lorentz theory that they believe. And I say, why are you calling it special relativity? And they're saying they're calling it that for historical reasons, because Einstein is the one famous for having started it. So they're actually believing in a different theory to what's being advertised.
Well, that would be easy for mainstream to solve then. All they'd have to do is basically say, oh, well, you know, we realize that the correct theory is this Lorentz theory and that Einstein's theory is wrong. I mean, that would be very easy for them to correct.
But
that problem pretty quick.
That actually messes things up, because Einstein is supposed to be the greatest genius ever, and then you have to then say, well, it was Lorentz.
Yeah, but science is supposed to be based
I know.
on measurements and experiments, and so they could say this is what the experiments show, and it's kind of embarrassing that Einstein turned out to be wrong, but we're scientists and we have to believe what the experiments show us is true.
Yeah, but then you got to try to convince them all to come out and say that, and that's going to be difficult.
Yeah, that's a tough thing. I've got Robert Bennett.
Thank you.
Difficult, really.
Yeah, well, thank you very much,
This
Roger.
meeting is in listen-only mode.
Robert Bennett on here. Robert, I've unmuted you. Are you there?
Yes, David.
Oh, there he is. Go ahead. I guess Harry wants to hear from you. So say something very important and enlightening, or I'll turn you.
Well, I think what Robert has been talking about recently, and I know you make a distinction between kinematics and dynamics, and I think that's kind of an interesting perspective.
Okay, just to comment on the inability of mainstream to accept what seems to be a contradiction to their worldview. It is possible to know the truth, which is an intellectual act, and yet to override that with the will, because the will sees something that is better. For example, you can know the truth, but be offered money or social status or a job or other worldly things, and that would override your knowledge of what is the truth, but accept something which isn't the truth for a greater good. So the philosophers throughout the ages have talked about this. Why do we do what we think is wrong, or what we know is wrong, and what is the motivation for that? Well, intellect and will is basically the focus of that discussion. The other thing you touched on is that that guy in Germany, Albert Einstein Institute, he's written something that I responded to. He has an article, all coordinates are equal. All coordinate systems are equal, which of course is a principle of general relativity. I responded to that, and I'll send it to Nick and to Harry for their comments. Now, as far as
I think I already commented on it.
Yes.
oh, I already sent it to you? Okay.
Yes, you did. Thank you.
Okay. Yeah, what I discovered was relativity means different things to different people. Physics basically is a study of motion, and it has two branches: kinematics, which is the study of the measurements, and that's purely mathematical. It's what do we use for describing motion? Velocity, acceleration, so on. And it's obvious to everyone that if two observers are looking at each other, they see each other in relative motion. The speed of one with respect to the other is equal and opposite. The acceleration of one is equal and opposite to what the other sees. And that, in fact, is so obvious, it's like a mathematical axiom. It's always true. So when people say relativity, that's one thing that they could mean, the relativity of kinematics. But here's what I've discovered. If you apply that to dynamics, what is dynamics? The prediction of motion. Not the measurement, the prediction. And it's based on variation of the Lagrangian, which gives you the equations of motion. Now, when you go to special relativity, or to general relativity, it uses the statement that the laws of physics, meaning the laws of motion, are valid in all reference frames. That's general relativity. That's called general relativity, but it's actually covariance. Covariance is the principle of having equality of reference frames. Relativity is what I just said, kinematics, the relativity of motion. So we're being scammed in one sense by being told that relativity applies to covariance, that is, to the equality of reference frames. It does refer to the equality of motion, but not to the equality of reference frames. And the classic example that refutes that is Newton's bucket. Newton's bucket shows that if you're in the bucket frame, you can't explain why the water rises and falls, because the water is stationary in your frame. This is a classic problem, over 300 years old, which hasn't been solved, and it basically comes down to proving that the world is not covariant. There are preferred reference frames, and the reference frame in Newton's bucket case is the Earth frame. So what I'm saying is that, number one, relativity applies to kinematics. Covariance, the equality of reference frames, applies to dynamics. And very simple experiments show that only one frame is covariant. And I've published a lot of things privately and on VIXRA that support that experimental proof. But that's the key idea that I've discovered that causes most of the confusion. If somebody says to me, do you believe in relativity? I say, yes, I do, for kinematics. I deny it very firmly for dynamics. And I can prove it very easily that relativity, in that sense of equality of reference frames, which is really covariance, does not apply to any reference frame except the Earth frame. And I guess it's very hard to accept this, which is a paradigm that shatters basically all of the beliefs of the last 500 years. But I've already proposed a relativity challenge. I think it's up to $200 that for anyone who can show me an experiment where the laws of physics are obeyed in anything else except the lab or the Earth frame. Nobody has shown me this so far. So in a nutshell, that's basically what what my premise is. You won't make any sense of this unless you accept my philosophy, which is realism. There is an objective reality. Things exist even if we aren't looking at them. They look the same to all of us if our sense faculties are normal. Causality is a firm principle of realism. So is the principle of non-contradiction, and that addresses what you were talking about before, the scientist who says I can accept different realities. Well, that is totally unacceptable in the philosophy of realism. There are no contradictions possible in a logically consistent system. Scientific method, I accept that, and I firmly believe in testability. I think most of the things that are rejected by mainstream can easily be rejected by us by the simple act of testing. In other cases, mainstream ignores the results of tests. So basically what's not impossible is possible. And I could go into the ether, which explains why, if Newton's laws don't work, why we can still have the observed cosmic motions. I'm sure there's no...
I have some questions, Robert. Relativity, what are you talking, I mean, relativity, you have general and special. What are you talking about when you say relativity?
By relativity, let's talk what mainstream means, right? You have the definition in special relativity of the equivalence of all inertial frames. I mean, the equivalence of the laws of physics in all inertial frames. Right, David?
Say that one more time.
Well, the first postulate of special relativity is that the laws of physics, the laws of dynamics, okay, the equations of motion are all valid in inertial frames, correct?
Yes, yeah, that's what I said, yes.
Okay, in general relativity, you just extend that to all reference frames are equivalent, okay? And now, what was your question?
My question was, yeah, whether how you talk about relativity, because I just have a couple problems, but I'll say one thing that I do agree with. It sounds like you have a lot of similarities in your philosophy and assumptions with Glenn Borkert. True or false?
Yes, some similarities, but also some differences. Yeah.
Okay. All right. No problem. And then how do you explain a couple of things, which is even though we talk about frames, the way I look at it, there's only one three-dimensional space. Frame is interesting only that you have to do measurements from one point somewhere in the universe. Is that something you agree with? When you talk about frames, I don't, there's mass and motion, but I mean frames in the way in Karazani, at least I can understand what he said, is that they're like, I don't even know what they are. There's no physical reality to me. I mean, you can only put a point from which you're going to measure something else. Is that something you agree with? Or I don't get what multiple frames mean, because in my understanding of the universe, there are no multiple things. There's one three dimension. We can pick a point and measure from there. That's all we can do. But okay. What's your observation on that?
Okay, what you're doing is confusing coordinate systems with reference frames. If you looked at the 1905 paper of Einstein, you would find reference frame is mentioned in the first paragraph, and then coordinate systems are used throughout the rest of the paper. He never defines either one. Coordinate system is a mathematical construct that allows us to identify a location in space. That's all it is. Okay? It has no physical meaning. In other words, to say I have a Cartesian coordinate system has nothing to do with physics, because you haven't identified where you're placing that system. Frame of reference requires an observer at the origin. So take a coordinate system and put an observer or a detector at the origin. Now you have a reference frame. That's the difference. So
okay, I gotcha. I think we're saying the same thing, maybe. How can you have multiple reference frames just because you have multiple observers?
Exactly. You're an observer. I'm an observer. Harry's an observer, right?
You might, if you might let me get in here, I'd like to help a little bit with this, David.
Sure.
This is very interesting what Robert's saying, and I think if we paid attention to what he's saying, we could clarify a lot. I see the word reference frame as being something that's attached to physics. And coordinate system is kind of basically an abstract mathematical concept. And so the words kind of become interchangeable, but then because reference frame has been used in relativity, a lot of people kind of get confused about it. So to me, I think there's a lot of terminological confusion.
Sure.
So I hope what I'd like to get to is the point that Robert said that he talks about covariance, and he also started off talking about all coordinate systems are the same. Isn't that what was the name of that article?
Coordinate systems are equal,
All
and the first.
coordinate systems are equal, right?
But he should have been saying all reference frames are equal.
Correct. You're right. Exactly. But that would have been an incorrect statement, in my opinion. But here's the thing. If you this is my opinion of it, Robert, you can correct me. My view is if you have a coordinate system or a reference frame and you transform covariantly into a different one, then you are doing the math correctly. But special relativity doesn't transform covariantly. It doesn't do the coordinate system transformations correctly to get the right physics. That's what the problem is. So if you go to the Marcus Possel webpage, website, which is what Robert was referring to, he gives the example of, well, two different observers seeing two different things isn't a contradiction. And the example he gives is a man and a woman sitting at the breakfast table, and they're opposite each other, and the man says, well, the salt shaker is behind the cream pitcher or something like that. And the woman says, no, it's not behind it, it's in front of it, because she's looking at it from a different point of view. Okay, do you understand what I'm saying?
Yeah, your perspective is determined by where you're located, by the.
Right, and so.
But the principle.
You have two different frames. You have the frame that the woman is in and the frame that the man is in, and they're looking in opposite directions. So the frames are oriented oppositely. Now the question is, now what Marcus Possel says is, he says that's not a contradiction. Okay, he says it's not, the two different descriptions of the observers doesn't constitute a contradiction. Well, that's because you can transform from one person's view to the other person's view, but the physical description hasn't changed. When you change the view of perspective, the one person says that the salt shaker is behind the pitcher, and the other person says exactly the opposite, that the pitcher is behind the salt shaker. Okay? And so Marcus Possel says, well, those are two contradictory statements, and so that means that you can have contradictory statements that are both true. But they're not contradictory statements. That's the problem. Do you understand what I'm saying here?
Yes, the distinguishing characteristic of the example you gave and reference frames is that yours is static. You're describing one observer who is at rest with respect to another and describing what they see, okay? As you say, that's simply a coordinate system change. Does that apply to what I said about dynamics? No, because dynamics requires at least a relative speed, right, between two observers. So,
right, I understand. What I'm trying to get at is, from my perspective, the two situations are covariant in that you can transform the coordinate system from one to the other, and you have not changed the physical description of what they're describing. They're both describing the same thing. Correct?
Yes, that's coordinate
transformation. What happens
transformation.
in relativity is The transformation of the frames, the two frames, they're not covariant. They don't describe the same thing physically.
Because they don't obey the laws of motion, unless it's the lab frame.
Well, I think it has to do with the way that the mathematics transforms, the Lorentz transforms are used. The Lorentz transforms don't transform covariantly in special relativity.
Once you establish that there's only one preferred frame, there is no more Lorentz transformations. There is no more Minkowski space. There are only Galilean transformations in Euclidean space.
Okay. Well, I understand what you're saying. It's kind of difficult to follow that part, and that's an issue that needs to be worked on, I think.
Harry, it took me 3 years to work through all of this, and I'm still working on it, but it was
I think that you're fundamentally right in your premise. We're just kind of disagreeing on terminology. But I think what you're saying is largely correct. It's my view.
Yeah, I'm saying that